Factoring quadratic trinomials with a leading coefficient greater than 1. Okay, so the last lesson was all that leading coefficient was 1. In this case, it's going to be greater than 1, which proposes a little bit more of a challenge. But before we get to that, let's just review distributing again and see if we can see any patterns similar to the way that we saw patterns before. So I'm going to run through these pretty quick. So I'm going to do 2x times an x. That would be 2x to the second. 2x times 3 would be 6x. 5 times x is 5x. And 5 times 3 is 15. Combine your like terms, we'll have 2x squared plus 11x plus 15. So let me just keep going. Let me do b as well. So 3 times x would be 3x squared. 3 times 2 is 6x. Negative 4 times x is negative 4x. Negative 4 times 2 would be negative 8. Combine your like terms. We'll have 3x squared. 6x minus 4x is 2x. And then you have your minus 8. So that's simplified there. Let me do the other ones. 2 times x, 2x. 2 times negative 7, negative 14x. 1 times x, just 1x. 1 times negative 7 is negative 7. Combine your like terms. Negative 14x plus 1x would be negative 13x minus 7. I'll quickly do this one. 2x times 3x would be 6x to the second. 2x times negative 2 would be negative 4x. Negative 5 times 3x would be negative 15x. And negative 5 times negative 2 would be positive 10. Combine our like terms. Negative 4x minus 15x would be negative 19x. And then plus 10. So I know I did those really fast, but that's just distributing. We did that earlier on in the year. So now I'm going to kind of look at this and see if there's a similar pattern to the way that we did it in the previous lesson when the leading coefficient was just like 1. So like maybe let me scroll back to the last lesson. Okay, I'm going to do that really fast. So back in this last lesson, what we saw was that this final number here, I'm going to circle it in green, was the product of the 7 and 3 up here. And this 10 was the sum of 7 and 3. That was the pattern we saw, even with, let's look at C. This negative 40 was the product of 5 and negative 8. And this negative 3 was the sum of negative 8 and 5. But let's look at this and see if we see the same thing. Well, what I do see here is that this, if we're just looking at the answer comparatively to the original expression, this 15, that's still the product. When you do distributing, that's still the product of the 5 and 3, right? 5 times 3 is 15. But this is where it gets a little annoying. We don't have that same pattern with that middle term. This 11x, 11 is not the sum in 5 and 3. 5 and 3 does not add to 11. So we can't use that property. It doesn't seem like here. Even on B. This negative 8, that's the product of negative 4. Negative 4 and positive 2. Negative 4 times 2 is negative 8. But negative 4 plus 2, we don't have that relationship with this middle term. That is not the sum of negative 4 and 2. Negative 4 plus 2 is not equal positive 2. That's not a relationship there. Even here, we still see, we have that relationship there. Whoops. Again, I'm just crossing this out so it's a little more clear as I explain. But the 1 times the negative 7 is negative 7, but 1 plus negative 7 doesn't equal that negative 13 middle term there. Okay, so it doesn't have the same relationship as when we just were dealing with coefficients of 1. It has that multiplication relationship with that third term, but that addition part isn't in that relationship when we have a leading coefficient greater than 1. So that's going to when it's not just a regular x and a regular x, where we have like, these 2s and 3s and 3s and 2s. Like this relationship isn't the same. So I'm going to get to this factoring here with these examples down here. Now, I just want to warn you, there are many ways to do factoring problems, and there's different methods. I'm just going to show you the guess and check method, and it may not seem so structured to you, but there are other methods that you can look up on your own that can help factor. So I'm just going to do guess and check. That's the way that I like to do it, because I don't like doing the whole memorization of a method sort of way. I want it just to be kind of organic and just guess and check until you get the correct answer. So here we go. Number 2 says factor the following quadratic expressions as a product of two binomials. So I'm going to set up my little parenthesis template. Now I have a 2x squared. So that means I know I'm going to have a 2x and an x here, because that's the only way I'm going to get a 2x to the second. Now that multiplication property still stays true. The numbers that go in these parentheses are going to have to multiply to 4. And that's really my only hint, is that they're going to have to multiply to 4. So they're not going to add to 9. There's no numbers that multiply to 4 but add to 9. So that addition property does not matter, does not work with these sorts of factoring problems. So I got to think what multiplies to 4. I just got to guess some numbers and check to see if after I distribute that I'm going to get that 9x. So for instance, you don't have to write this yet, but let's just say I'm guessing 2 and 2. Because 2 times 2 is 4. Now to see if I'm correct, I would distribute. 2 times x is 2x squared. 2x times x is 2x squared. 2x times 2 is 4x. 2 times x is 2x. 2 times 2 is 4. Like terms combine to 6x. And that's my expression when I distribute. So now I look, is that the same as a 2x squared plus 9x plus 4? No, it is not. This has a 6x. This is wrong. That's not correct. So that means I factored it wrong. So I'm going to erase all that. It's wrong. Let me erase that. So 2 and 2 going there is incorrect. So let me try something else. What else multiplies to 4? Well, 4 times 1. So maybe I do a 4 times 1. But the question, it does kind of matter. Where do I put the 4 in the first parentheses and the 1 in the second? Or should I put the 1 in the first parentheses and the 4 in the second parentheses? You got to kind of figure that out. And the more you do this, the better you'll get. But let me show you the wrong answer first. Don't write this yet. Let's say I put the 4 here and the 1 here. Well, if I distribute, I'll get 2x to the second. 2x times 1 is 2x. 4 times x is 4x. 4 times 1 is 4. So this gives me a 6x again. I need a 9x. So that's going to lead me to believe that I need to put the 4 in this parenthesis and the 1 here. And let me show you why that works. 2 times x is 2x squared. 2x times 4 is 8x. 1 times x is just 1x, and 1 times 4 is 4. The 8x plus the 1x equals 9x. Check. That's correct. 2x squared plus 9x plus 4. So this is guess and check. So you guess and check. And eventually you'll make educated guesses. For instance, I would have guessed this straight from the start, because I know if I do a 2 times the 4, that's going to get me an 8x. And then that'll be really close to my 9x. And the 1 times the x is 1x, which will give me that 9x. So you'll get better as more times you guess and check. Now, I know this is just example 1, but if this guess and check concept is totally a mess for you, there are other methods to factor. And I encourage you to look them up if you need to. But this is the answer for this one. I'm going to jump around a little bit. So let me do D. Set up a template. I need a 2x and an x again to get 2x squared. Now I know these numbers in this parentheses, they are going to have to multiply to negative 15. It still has that property where the numbers multiply to negative 15. So there's not all that much that multiplies to 15. We got 1 and 15 and 3 and 5. And those numbers, when I distribute, are going to have to combine to this negative x. So maybe I can be a little bit more strategic with my guessing here. So I'm going to try with 3 and 5. And my mind's already thinking to this. If I put let's say a 3 over here, that's going to give me a 6x, right? And then maybe if I put like the 5 over here, that's going to give me a 5x when I distribute. Now it needs to get me to a negative 1x. So I'm going to say this is going to be a negative 3 and this a positive 5. And let's see if it works. So this is my guess. I think this is going to work because a 2x times a negative 3 would give me negative 6x. And a 5 times an x would be positive 5x. And negative 6x plus 5x is negative 1x. So I think this is going to work. But let's just check it. So 2x times x is 2x to the second. 2x times the negative 3 is negative 6x. 5 times the x is 5x. And 5 times the negative 3 is negative 15. And those two middle terms combine to negative 1x, which is our original expression. This is the same, so that means it's factored correctly. Show this one. So we need a 3x squared. So I know I'm going to need a 3x here and an x here. Now these numbers that go in here have to multiply to 10. So it could be 10 and 1, and it could be 5 and 2, could be 2 and 5, could be 1 and 10. Like it could be any sort of those combinations about where you put those. So we have to, again, the way that I like to do is just kind of guess and check. Now let me show you a wrong answer. And let me show you a kind of a bad guess, okay? Because there are some bad guesses. Let's say I do 1 and 10, because 1 times 10 is 10. This would be a bad guess, because if I put, let's say, a 10 here, that's really not a good guess, because when I do 3 times 10, that's going to give me a 30x, and that is so far away from the 17x. That's not a good idea, right? And, I could show it out to you if I need to. It would be 3x squared. The 3x times the 10 is going to give me 30x. The 1 times the x gives me 1x. So this is going to be a 31x. And it's not 17x. That is a bad guess. So I'm going to erase all that. That's a bad guess. Because I'm trying to get to that 17x. So maybe a better guess is maybe use 5 and 3 or 3 and 5. And here's not 5, multiplies to 10. So 2 and 5. So we use 2 and 5 or 5 and 2. So here's a good guess. If we're trying to get to 17, it might be a good idea to put the 5 here, because 3 times 5 when I distribute is 15x. And then put a 2 here because that will give me a 2x, which make the 17x. So that's where kind of some strategy comes along when you're making guesses. This shouldn't just be a total blind guess. Try to use, some logic in it. So this is it. Now I kind of already have it, but just to double check, let's just distribute 3x times x would be 3x to the second. 3x times 5 would be 15x. 2 times x is 2x. 2 times 5 is 10. This combines to make 17x. So there we go. Check, that is correct. This is the correct factorization. All right, let me do some more. I'm going to do g, 3x, x, because I need that 3x to the second. Now it's got to multiply to a positive 4. Whoops. It's got to multiply to a positive 4. Yet the numbers when you distribute are going to combine to a negative 13. So what's that's going to tell me is that both of these need to be negative. I'm just going to put that there right now. Okay. So again, what multiplies to positive 4, but it's got to combine to a negative 13. So it could be negative 2 and negative 2. Could be negative 4 and negative 1, because those multiply to positive 4. It could be negative 1 and negative 4. But this is where the guessing, this is where you want to be a little smart with your guessing. Like if I just put, I got to get all the way to negative 13 when I combine. If I just put 2's here, I don't think that's going to get me to the negative 13 that I need. Because a 3 times 2 is negative 6x, and then that's just another negative 2x. That's not going to get me all the way to negative 13. So a smart guess would be maybe do a 4 and 1 and put the 4 here. Because a 3x times 4, negative 4, will get me to negative 12, which is quite close to negative 13x. And then if I just put a 1 here, this might work. So just to check, 3x times x would be 3x to the second. 3x times negative 4 would be negative 12x. Negative 1 times x would be negative 1x. Negative 1 times negative 4 is positive 4. So then I have a 3x squared minus 13x plus 4. And yep, that was the original expression. So that's correct. I'm going to erase this. Because remember, what I was doing there was just checking. That's not a part of the solution. The solution is just this. Remember, it's a guess and check game. Okay, let me show you I. So I'm going to set this up. Now this one can get even more challenging because I have a 6x squared. So I'm not exactly sure if I need to do a, don't write anything yet, a 6x and an x. But there's also another option there because a 6x has more than, it's not prime. I could do maybe a 3x and a 2x. So there's going to be a lot of guessing and checking with this one. Lots of guessing and checking with this one. But what is nice is this last number is prime. The only thing that multiplies to 2 is 1 and 2, or 2 times 1. So we know that's going to have to go in those kind of blinks there. So let's get on with the guessing and checking. So I'm not exactly sure. So what if I restart this and just put like a 6x and an x here? So now I'm trying to play around with it. Say I put, I don't know, I need to get to negative x. So if I put a 2 here, now that's going to get me all the way to 12x. That's not going to be good. Maybe if I put the 1 here and a positive 2 here, well, that's going to get me negative 6x. That's going to get me to 2x. So that'd be negative 4x. That's not going to give me negative 1x. So I'm kind of running out of ideas with that. So maybe I'll erase that. Maybe we can try the 3x and a 2x. That gives me 6x squared. And then maybe I put a, so it's got to multiply to negative 2, these two numbers in here. So, you know, I might not want to put, again, maybe I'll put the 1 over here instead of the 2, because if I put a 2 over here, that's going to get me up to a 6x. I'm trying to get to a negative 1x. So maybe if I just put like a negative 1 here, maybe. And then maybe that means I would have to put a positive 2 here, because positive 2 times negative 1 is the negative 2 up here. So let's check to see if this works. So 3x times 2x is 3x to the second. 3x times negative 1 is negative 3x. 2 times 2x is 4x. And 2 times negative 1 is negative 2. These combine to 1x, right? Negative 3x plus 4x is positive 1x. So I was so close. We need a negative 1x. So maybe just a little adjustment. What if instead of doing positive 2 and negative 1 up here, I did negative 2 and positive 1? Now let's check that. So 3x times 2x is 6x to the second. 3x times 1 is 3x. Negative 2 times 2x would be negative 4x. Negative 2 times 1 would be negative 2. Aha. 3x minus 4x is in fact negative 1x. Therefore, that's the correct factorization. And there you go. So again, this is guessing and checking. And there's, again, with these, there's no race with these. When you use the guess and check method, you just take your time, guess, check, guess, check, guess, check, guess, check. Okay? Like I said before, there's multiple methods to doing this, but this is the way I'm showing it. So let me just show you J really fast just to give you another one. So I got 8x to the second. So this, again, it's kind of annoying because we have an 8x to the second. So it could be the 8x and the x, or it could be a 4x times a 2x. So I'm going to start with the 4x times a 2x. Okay, I'm just going to try that out. So it's got to multiply to negative 15. So I'm probably working with 5 and 3 or 3 and 5. It's got to combine to negative 14x. So this seems kind of a challenge here. So I need to get to negative 14. So this is what I'm thinking. If I put a negative 5 here, that 4x times the negative 5 is going to get me all the way to negative 20. 4 times negative 5 is negative 20. So I'll have a negative 20x. And then I can put the 3 here to multiply to that negative 15. And I'm thinking that 3 times the 2x gives me 6x, and negative 20 plus 6x gives me that negative 14x that I want. So let's check my answer. 4x times 2x is 8x squared. 4x times negative 5 is negative 20x. 3 times 2x is 6x. 3 times negative 5 is negative 15. These, in fact, negative 20 plus 6 is negative 14. That means I have factored this correctly. So I know I've been saying, okay, guess and check, guess and check. Like, I guessed correctly on my first try, but that's only because I'm a math teacher and I will make good guesses. I've done so many of these, and you will get better and better at your guesses as well. Okay, you'll get better and better at your guesses as well. So keep that in mind. Okay. Let me show you a couple special cases. So Q and R are, and even S and T are a little bit special cases with this because there's a little cheat that you can do to start this problem out. Since all these coefficients are even, I can actually factor a 2 out of that entire expression to make this easier. So what I can do is take a 2 out. So I'll have an x squared plus 7x plus 10. Hopefully you see what I did there. And then I can factor that x squared plus 7x plus 10. And the reason why this is so great is because, remember, now it's a leading coefficient of 1 like the last lesson. Now I can just say, okay, what multiplies to 10 and adds to 7? 5 and 2. So sometimes you can get it to a leading coefficient of 1, which I think is easier like the previous lesson. So this one, same thing. These are all divisible by 3. Factor out of 3. So now I just have a leading coefficient of 1. So I can just do the easier x, ask myself what multiplies to 5, yet adds to 6, would be positive 5 and positive 1. So yeah, those are just kind of some special cases with that. But I said it a million times, guess and check, guess and check. If this guess and check method doesn't click for you, there are other methods out there. There's like, I used to kind of show the some people try to use the area model with it. There's the AC method. There's like this thing called the AC method that I've used before. Yeah, so you can go and research those sorts of things if you'd like. But this is the guess and check method. I'll let you try the rest.